Math 3, Unit 6, Section 5. Today we're talking about rational exponents. What are exponents? Okay, they are numbers. Good. These can also be thought of as your powers. Okay. Rational exponents are basically fractional exponents. Okay. And so if you look through here, you have some notes. But look here at where we have x to the 1 over n power. The n, remember, represents your index or root. And then the 1 is the power that goes with the inside portion. Okay? And this is a review. We did this earlier this year, correct? Okay? So we're just going to go and skip right down here. So this says to write each expression in radical form. So in this case, the 8 is the what? The 8 is your index or root value. And then the 5 is your power or exponent. So if we rewrite this, it is the 8th root, good, of w to the 5th power. Do you remember what happens when we have negative exponents? Good, it changes sides. We flip it. And so that negative 2/3 is going to go where? Yeah, this negative 2/3 is connected to the t, and it's going to go to the denominator. And so now we have t to the 2/3. And if there's nothing on the top, there's actually a what? A 1. And if we rewrite this, how would it be rewritten? Very good. 1 over the cubed root of t to the 2nd power. Now, is this an okay statement to have? No. Why not? Can't have a radical in the denominator. And so what would I need to do in order to eliminate the radical in the denominator? Good. How many do I need for a group? 3. And so I have 2 right now. So if I multiply by the cubed root, I don't know what I just did that. Cubed root of t, that would give me a group of 3s. 3 t's, correct? But whatever I do to the bottom, I also have to do to the top. So we do have a group of 3 t's, which now makes my denominator t, and then my numerator will be, yeah, because 1 times the cubed root of t is just the cubed root of t. And how come that can't be simplified?
Because one's under a radical and one's not.
Very good. One's under a radical and one is not. In order to reduce, they both have to not be in a radical or both have to be in the same index of a radical. Okay, so next we have y to the 2.6. I would change 2.6 to a fraction. How can I change that to a fraction?
26 over 100.
Close. Y equals 26 over 10. And why is it just 10? Because, yeah, it's only out to the 10th place. Remember how many decimals there are? That's telling you, like, what place it's going to. So right now, it's 1 decimal, and so it's to the 10ths. Okay, and then what would I do with, can I reduce that? Yeah, so I'd reduce it to make my life a little easier. And so when you reduce that, what is it going to be? Good. And then how would I change that to radical form? Good. The 5th root of y to the 13th power. And could I simplify that? Yes. How would I simplify that out?
Y squared.
Good. Y to the 5th. Y to the 5th. And then y to the 3rd. Because I need 5 for a group, correct? And so that's 5, 10. This makes 13. That part's left over. And so how do I end up writing that answer? Perfect. You guys got this. Y squared and then the 5th root of y cubed. Any questions before moving on? Okay, this next part is where we're going to change them from radical form into exponential form. And so how would I rewrite the 4th root of x cubed into radical form? Perfect. X to the 3/4 is correct. How would I rewrite the square root of 10? Very good. 10 to the 1/2. So remember, if the root doesn't give you an index value, we know it's a 2. And if the value in here doesn't have an exponent, it has an exponent of 1. And so that is 10 to the 1/2. Okay, this one's a little different. So recognize that this 2ab, that whole thing, is being raised to the 12th power. Are we okay with that?
Yes.
How would I rewrite that one right now? 2ab in parentheses raised to the 12/4. And I heard Kenneth say that 12/4 would reduce to 3. So I really have 2ab to the 3rd power. This answer would be acceptable, but could I simplify that further? How would I? Could I put this 3rd power to each of these things inside?
Oh, yeah.
Yeah. How come I can do it here, but on other ones I can't do it? There is parentheses, so it means that this whole thing is to the 3rd power. Also, there's no adding or subtracting in here. If there was adding or subtracting, then I would need to use either my Punnett square or write them out multiple times and do the distributive property. Okay, but in this case, because it's a single term, 2 to the 3rd power is 8. A to the 3rd power is a to the 3rd power, and then we have b to the 3rd power. So either of these answers is acceptable. Do we have any questions before moving on? Okay, so before turning the page, these properties may be useful for some of you at some point. So you might want to like highlight or star them. We're going to be using these properties when we are solving some of the following problems. But it's important to remember that when you have the same base, your exponents, you can combine them and you add them, right? And when you have powers to powers like this, you end up multiplying the two numbers together, the two exponents. Yes, do we remember all this? Okay, if you have a negative exponent, change sides. And then if you have the same base and it's dividing, you can just subtract the exponents. We're all good with this? Okay. So here we are just simplifying multiple problems. I noticed that there are some errors here, but we'll figure it out. Okay, so 64 to the 1/3, what is going to happen there? Very good. This would change to be this cubed root of 64, and what is the cubed root of 64? 4, because it's 4 times 4 times 4, so we have our group, and the answer is 4. This one right here, where it has a box, that should actually be a multiplication there. Now, do both of those have the same bases? Yes. Do you see how they both have -2 as the base? So we can keep -2 as the base, and then what do you do with the exponents? Add them together. So I'm going to write this out just so that I have it written in my notes. But 2/5 plus 3/5 adds to be what? 1. So we have -2 to the 1st power, which is just -2. Okay, what happens with the 11, base 11? Yes, because if you have the same bases and they're multiplying, you can add the exponents. So I was just showing that I was adding those two exponents together to get 1. Okay, so the same thing happens on the 11, and we end up with 1/2 plus 1/2, which is 2 over 2, good, which reduces to 1, which is just, which reduces to just be 11. Okay, on this next one, do you see how they are not the same base? So in this case, this is why it's good to know that you can change things from radical form to exponent form and vice versa, because let's change these both to radical form. So 3 to the 1/2 would end up being what? The square root of 3 times 12 to the 1/2 would be the square root of 12. Can I simplify these now? Yeah, do they both have the same index? Yeah, and so we would go ahead and have the square root of 3 times 12, and then can I break that down further?
3 and 4, you can put the 2 3s.
Good, 3 and 4, and we have a group of 3s, and then the 4s would break down to 2 and 2. We have a pair of 2s, and so this answer would end up being good. All right, what's going to happen on the next one? We're going to what? Oh. So negative numbers are okay. It's negative exponents that are not. So this negative is okay. There's nothing I can do right now, though, at this point. So could I change this to radical form and see if it can be simplified? Yeah. Yes. And so what would be the index for this? 3. So the cubed root of our value is good, negative 27 to the 4th power. Okay, so you could write this out as negative 27 times negative 27 times negative 27 times negative 27, correct? Okay. So we'd need to take the negatives out, which would end up making a imaginary numbers only come with even roots, correct? So what happens when you have so many negatives? It'll end up making a positive, right? 4 negatives is a positive, correct? Okay. And so you can think of that as the cubed root of, well, what, I can still write this. Do you guys agree that there are 3 negative 27s?
Yes.
Okay, so we could write this as negative 27, but we still have a negative 27. Do you guys agree? Well, when you bring this negative out, what happens? It becomes a positive. And then, so we have 27, cubed root of 27, and then that 27, can it break down? What does it break down to? 3 times 3 times 3, which is a group of 3s. And so we end up with 27 times 3, which is 81. Now, we kind of went through a long way on this. There was another way we could have done this. So I'm going to show you just one more thing real quick for this problem. Another way we could have written this was the cubed root of negative 27, and then you could put this whole thing to the 4th power. Okay? Do you guys see this? Okay, so if we took care of the negative and brought the negative out, we would have negative cubed root of 27 to the 4th power. We know that 27 ends up becoming 3. And so we'd have negative 3 to the 4th power, which still gives me 81. So it's just another way to look at the same problem. So sometimes it's easier to just simplify the root and then raise it to a power, and then sometimes it's easier to have the power under the root. Either way, though, you're going to get the same answer. Do you see that? How here I had the 4th power under the root, and here I simplified the root and then took it to the 4th power. Okay. Do you want to ask me questions? What happens when I have powers to powers like this? They multiply. What is root 3 times root 3? So we have 5 to the root 3 times root 3, which is 5 to the third. And 5 to the third power is 125. Okay, the way this is written right now, can I simplify these? No. When you can't simplify them the way that they are, try rewriting them. So how could I rewrite these problems or these terms? I can write this as 3 to the 1/2. Do you guys agree? Times, and this would be 3 to the 1/4. Do these have the same base? Yes, which means I can add the exponents. Can I add 1/2 and 1/4 as they are? Very good. I can't because they need common denominators, correct? And so we would need to change them to have common denominators. So what would be a common denominator for 1/2 and 1/4? Good, 2/4. Do we agree that we can multiply the top and the bottom by 2 here? And so we end up with 3 to the 2/4 plus 1/4, which means my answer is going to be 3 to the 3/4. Okay, are you seeing why being able to change things from radical and exponential form is helpful, so that sometimes we can simplify things that maybe didn't seem possible to be simplified prior? Okay. All right, what are you going to do with this next problem? Do they have the same bases? Yes, so we are going to do what? Very good, add the exponents. So we're going to have x to the 4/3 plus 5/6. Can I add fractions the way those are right now? Nope, and so we would need a common denominator, and what would be the common denominator? Good, 6. And so we'd have to multiply that first fraction by 2 to the top and the bottom, which would make 8/6. I heard someone say, good. Plus 5/6, and when we add that together, we get x to the 13/6. Good. And this is an acceptable answer. You could also change it to like root form and simplify it further if you wanted to, but okay, what is going to happen with this next problem? Very good. We're going to bring it down. Do you see how it's saying this whole parenthesis is to the -1 power? So whatever the -1 power is touching, you have to move everything that's touching. So in this case, it's the whole thing is going to move to the denominator. And so now I would have 5x to the 3/4. And since it's all to the first power, I'm just not going to write it to the first power anymore because that's not going to change anything. And if nothing's on top, there is a 1. Okay, is it okay to have an answer like this? The answer is no. And do you want to know why? Because this right here actually represents a what? A radical. And can we have radicals in the denominator? No. And so I'm going to rewrite this so that you can see it better. So this is really 1/5. The 3/4 is only touching the x. And so this means that we'd have the 4th root of x to the 3rd power, like that. Does this make sense why this is the only thing in the radical? Okay, what would I do in order to eliminate the radical in the denominator? Good, we need one more x, so that means we're going to multiply by the 4th root of x, and whatever we do at the bottom, we also do to the top. And right now, that means that I'm actually multiplying by what value? 1. We have now our 4 x's, and so my denominator is what? Very good, 5x. And my numerator is the 4th root of x times 1, which is just the 4th root of x. Do we have any questions before moving on to the next one? Okay, are we good? On this next one, can I simplify under these roots right now? Very good. They have different indexes, so we can't. So the way they're written right now is not great. So what should I do? Turn them into fractions. Turn them into rational exponents. And so the top, that would be rewritten as x to the what? X to the 3 over 2, right? So it doesn't have an index, it has an index of 2. So this 3, power goes to the top, index is the bottom. Okay, and then we go to the bottom, and that would be written as x to the what? Good job. And when we have division, what do we do with the exponents? Subtract them. And so remember that you always take the top, or the numerator, minus the denominator. So we have 3/2 minus 2/3. Can I subtract the fractions that way, the way they're written? No. What do I need? Common denominators. What would be my common denominator? 6. And so in order to make this a 6, we multiply this numerator and denominator by 3. And on this one, we'd multiply the numerator and the denominator by 2. And so we end up with what? 9 over 6, right? Minus 4 over 6. And then now we can subtract, and we get x to the 5 over 6. All done. Is that okay? Okay, so I would write this one right now as a fraction maybe, just so I can visually see things a little bit better. And so I'd have y to the 3/5 divided by y to the 4/10. Would it be helpful to turn that into radical form? No, because why? Yeah, it's easier to simplify this way, I agree. Also, these wouldn't have the same indexes, correct? And so because it's dividing, we can do what? Subtract. So we have y to the 3/5 minus 4/10. But we need to do what? Common denominator, which would be 10. Good. And so we have y to the 6/10 minus 4 over 10, which would make y to the 2/10, which is? Very good. Okay, questions? What does this 1/2 power mean? The whole thing is under a square root. Also, if the whole thing's under the square root, you can really think of it as the top is under a square root and the bottom, or the denominator, is under a square root. So however you want to write it, you can. So again, the whole thing is 50x to the 16th power over 18y to the 8th. Now, because they are both under a root, what do I know? I can reduce them. So what can 50 and 18 both reduce by? 2. So 50 becomes, and 18 becomes, and can I reduce any of the x's or y's? Yes. Well, I can't reduce them this way, right? But I can take out groups. Is that what you guys are saying? Okay. And so I'm just going to rewrite this. I have the square root of 25x to the 16th over the square root of 9y to the 8th. Because it's a square root, how many do I need for pairs? 2. So it's up to you, and I know a lot of you can do this in your head, but we know 25 is 5 times 5, so I have a pair of 5s. Correct? And then we'd need to count in 2s. So for the x's, if I counted, I'd have 2, 4, 6, 8, 10, 12, 14, 16, which ends up making how many groups? 8. So my numerator is 5x to the 8th power. My denominator, my denominator, we have 9, which is 3 times 3. And then counting in 2s to get to 8, I'd have 2, 4, 6, 8, which makes how many groups of y's? 4. So we end up with 3y to the 4th power. And can I simplify that any further? No. Questions before we do the last problem? Okay, what do you notice first about this last problem? It has some negative exponents, and what should I do with the negative exponents? Yeah, move it to the opposite side. So this is only touching that y, so that would go to the denominator, and then this one would go up to the numerator. And so I'm going to rewrite the problem without negative exponents. So in the numerator, I still have x to the 1/5, but this time now I have y to the what? 1/2. And then in the denominator, I still have x to the 1/2, and then now I also have y to the 1/5. Because they are dividing, and if you have like bases, we can subtract the exponent. So I have x to the 1/5 minus 1/2, and then I also have y to the 1/2 minus 1/5. Again, notice that you're always subtracting the numerator from the denominator. Okay, but they both are going to need what? Common denominators. What would be my common denominator? 10. So this we'd multiply by 2 and 2, and then 5 and 5. And so for the x's, excuse me, I would have x to the 2/10 minus 5/10. And then for the y's, we're multiplying them, the first fraction by 5, the second one by 2. And so we have 5/10 minus 2/10. When we simplify that, what do we get? For the x's, it's going to be to the negative 3/10, and for the y's, it's going to be positive 3/10. And is that an acceptable answer? No. What would we still need to do? Good. Move this one negative exponent to the denominator. And so now I have y to the 3/10 over x to the 3/10. Is that acceptable? What does that 3/10 represent? A root. So is that okay to have that in our denominator? No. And so if you wanted to, you could change these both to radical form. So this is the 10th root of y to the 3rd. And this is the 10th root of x to the 3rd. And what would I need in order to rationalize this? Very good. The 10th root of x to the 7th power, because we need how many for our group? 10 total, right? So that makes 10. And so my denominator is x, but whatever we do to the bottom, we also have to do to the top. Now, can I put these together? Yes, because why? They do have the same index. And so this is the 10th root of x to the 7th, y to the 3rd, just because I like to write things in alphabetical order. And that is your final answer. Do we have any questions?